Ask a JavaScript developer, bro, what is the most complex topic in JavaScript? I'm sure the person is going to tell you about asynchronous JavaScript, memory management in JavaScript, and in most of the cases, you will hear one more term called closures. Yes, it is true that closure sounds like a very complex and advanced topic in JavaScript, but in reality, it is not at all a complex topic to deal with, provided you have a good understanding of scope, functions, how inner function, outer function works, and you understand what is lexical environment, what is lexical scoping is, which we have already covered in the last 10 days of 40 days of JavaScript, and that's why we are going to extend it to understand closure today. Hey, this is Tapas. Welcome back to the 40 Days of JavaScript initiative. Whoever taking this particular initiative along with me, I'm sure that you are learning something new. And with that, we are also going to dive into understanding closure, not only fundamentally, but also with a lot of examples and with real life problems. So stick with me, learn, understand, and at the end of it, whatever the task given, please do those tasks. After this 40 days, I want to make sure that each of you are very comfortable with JavaScript and able to deal with any nuisances of it. Not only that, on any libraries and framework that are built on JavaScript, you will be able to tackle them very easily. All right, so let's get started with closure. And if you like this video, please post a like, please post a comment letting me know like what do you feel about it. And if you're still thinking to subscribe, please do, because I don't think you will be disappointed. Let's get started. To learn closure, you should have an understanding of inner and outer functions. You should have an understanding of scope. What is inner function and outer function? A function that got another function inside it. The function inside it is called inner function, and the inner function will be placed inside an outer function. That's how we know what is inner function and outer function. Excellent. Now, from the scope perspective, there is one more thing that we know. The function, which we call inner function, which is placed inside an outer function, can access any variable that is declared in outer function. So if we have a variable declared over here in outer function, the inner function can access this variable from here. However, from outer function, you cannot access anything that is defined inside the inner function. So this is not possible, and this is possible. Now, with this thing in our mind, we are going to define something called closure. So what is closure? In a very layman language, you can take it in this way that a closure is a function that can remember the variable from its outer function even after the outer function has executed. Okay, you can remember it in this way. So closure is a function, maybe this function, that can remember the variable of its outer function. Means it can remember this particular variable even after the outer function has been executed. Means outer function's execution is done, but still the outer function's variable, the inner function, can remember in some way. If you have such function, if you have such inner function which can remember the variable from outer function even after outer function got executed, then that inner function is what you call closure. This is the definition. I want you to keep it in your mind. No other technical jargon, no other heavyweight definition. This is a very simple definition. Why I want you to remember this definition? Because this definition directly connects to inner and outer function and the scope I just now explained. Now, if we think little more technically, and if you have to answer little more technically, like what is closure, you can tell in this way. A closure allows a function to access a variable from its outer scope even after the outer scope finished the execution. Same thing like this. A closure that can access a variable from the outer scope even after the outer scope finishes its execution. So either you tell in the previous way or this way, the meaning of closure is exactly same. Now let us understand the same thing with some code. Let's take a simple function called outer. Inside outer function, let us create a variable called let x equals to 10. And then let's have a function called inner, and here let's do a console.log of x. Now let us execute inner and let us also execute outer. So here in the outer function scope, I have a variable called x. Now from the inner function, I am accessing this variable x because we have just now learned that from the inner function, you can access the variable from its outer function scope. So we are able to access this. This inner function is lexically inside this outer function. What does lexically means? We have learned that in the execution context session already. Now, this inner function is lexically inside the outer function. So it means that the inner function is able to access this variable x because of its lexical scope. Okay, so this inner function's lexical scope is this entire thing that is there in the outer function, and any variable that is defined in the outer function, it will be able to access. Now here I am executing inner, and after that I am executing outer. So what will happen? Definitely the outer will be executed, and in the execution phase of its function execution context, when inner gets executed, inner will be able to execute this console.log and print 10 because it has an access to this x variable. As output, we are able to see this 10 as well. This is great, but is this closure? Not yet, because as a definition of closure, what we said is that the inner function can access the variable from outer function, which we have seen is true. But the final part was more important. Inner function can access the variable from outer function even after the execution of the outer function is over. Now here outer function is this one, and the execution of the outer function is over here. But after this, I don't know really that inner function can access this outer function variable or not. I don't have any way to know it. The only way that I can know and I can be certain about it, and I can figure out whether this is a closure or not, if instead of executing this inner function within the outer function itself, if I just go ahead and return it from here. Now the situation is a bit different. What is this outer function is returning? It is returning another function. Fair enough. Now as it is returning another function, I can create a variable, say const func equals to outer. Correct na? If it is returning a function, I can definitely take that return value inside a variable. Excellent. Now, at this line, line number 12, the execution of the outer function is over. If I go to line number 13, outer function is no more existed because the execution is over. But the beauty of it over here is, if I do a console.log of func, I am going to get this entire inner function because this is what the outer function was returning. And if you see, this inner function is having a console.log of x. Now at the top of it, I had defined this let x equals to 0, but this was part of the outer function which has been executed already. Right now, it has only this much, an inner function inside that console.log of x. At this time, you really don't know what is the value of x because the outer function has been executed already. But the beauty of it, as it is a function, inner function, you can now give a parenthesis around it to execute it. And the moment you execute that, it is going to print the value 10 because at the line number 7 over here, you are printing this console.log. Now understand the power of it. Your outer function's execution is over. At this point of time, outer function doesn't exist, but inner function was accessing a variable from the outer function which had a value. That value you are still able to access even after outer function execution is over. Now, at this point of time, as a consumer, you may not even know like what was the value of x was in the outer function because outer function is already done with its execution. But you are now getting back that value only because of the power of this inner function is returning this value to you, or it is printing that value somewhere, or it is doing something with that value. So this outer function variable, whatever the value of it x, it is completely private to this particular outer function, and it may also happen that it is never ever going to get exposed through this inner function. Finally, a computed value only getting exposed. That is the power of closure. Let's take another example very quickly to understand that. Let's do function outer count, and inside that let us take let count equals to 0. Then we will return a function from here. We will say inner count, and what this inner count does, it does a count plus plus, and then it does a console.log of count. Simple. So that's all about the function. There is an outer function that has a count as a variable, and it returns another function, another inner function which has the access to the count variable. Now, instead of just printing the count's value, here we are incrementing the count value and then we are printing. Means we are doing something with the count value that is inherently not belong to inner function. It is actually from the outer function. Now, the twist is if I take this outer count and then create a variable and assign the return value of this outer count, what will be the outer count return value? It will be this particular function itself, right? So read val will be a function. Now if I do read val first time, what do you think will be the output? So read val is nothing but this particular function, because outer function is returning this function. So read val is this function. Readwire had the access to the count variable and it incremented the count variable. So count was 0, now it will become 1. So console.log will be 1. So here it will be 1. If I do it once more, what do you think the output will be? Is it going to be 1 again or it is going to be 2? I say it is going to be 2. If I do once more, what will be the value of it? Is it going to be 3 or it is going to be 1 again? I say it is 3. Now let's see the output and we'll come back to understand from the explanation. As we expected, the output is 1, 2, 3. Now understand like why the output is like this. It is because this inner count function still holds the reference to this particular count variable from its outer lexical scope. This is where you are finding closure is in action. It closed the variable count in it so that first time when you return, the count value was incremented first time as 1, right? That's why you got it over 1. Now again, when you do this read val, it is not going to start from the outer count. It is not going to execute the outer count function at all, because outer count has already been executed in this line number 24 and it is gone. It is no more there in the picture. But the beauty of it, whatever the value of the count it closed on, a closure always close on a value of a variable from its outer function. So that's why we call it closure. So this is where it actually closed the value from its outer function and it got into 1. Now again, if you call this one, it remembers, this is the memory of the closure, it remembers the previous value that is closed on. It was 1 and then next time it will be 2. Then again, if you call, it was 2, then next time it will be 3. It is never ever going to reinitialize this count with 0, because this outer function, the outer count is no more into picture after its first execution, through which it had already returned this inner count closure to you. This is the power of closure. One more thing to note over here, this count variable we are never ever exposing outside directly. It is behaving like a private variable, isn't it? Because we are never ever allowing user to access this count variable directly and modify it. Rather, through the closure, we are putting an access to this count variable and able to do anything with it without making it public to the outside consumer. So for example, readval doesn't have to know the shape of count, doesn't have to know what count is. What it is only bothered about is like, what are you doing with this count variable and what are you finally returning based on your use case. Talking about the use cases, let us now start looking into some of the real world use cases that you can solve using closure, so that this concept become much more firm in your mind and brain. Let's do that. In programming, there is a paradigm called data encapsulation. Data encapsulation means you don't expose your private variables or the private data to the outer world. If they have to do something with that private data or the private value, they will be always accessing it through some methods or through some functions. So it means you expose the functions, you expose the functionality, but not those variables which take part in that functionality. Let's take an example, a real world example of a banking system. For example, we can create a bank account, we can check the balance, we can deposit money, we can withdraw amount, we can do all these things, but with the concept of closure. So let's take a function, say create bank account. And when you create a bank account or open a bank account, you can open the bank account with an initial amount, right? Or the initial balance. Now, this initial balance can be 0, initial balance can be 100 rupees, whatever it is that you can get started with. Now, let us create a variable which we don't want to expose directly. And let us call this variable as balance. Now, when we are creating the account, if there is an initial balance with what we want to open our account, we can initialize this balance using this initial balance. That means my balance will always start with $100 if I'm creating this bank account with $100. If I'm opening this bank account with 400 rupees, my initial balance is 400 rupees. But here point is, I'm going to create three functionalities. One is checking the balance, second is depositing the amount, third is withdrawing amount. Now while all these functionalities takes place, for example checking the balance or depositing the amount or withdrawing the amount, your this balance variable will be impacted, isn't it? For checking the balance, you will be printing the balance variable value directly. For depositing whatever the amount you will be depositing, you will be adding that used with your existing balance, and then that will be your new balance. If you are withdrawing, you first will check whatever the amount you are trying to withdraw, whether that much balance you have or not in your account. If you don't have that much balance, you are going to say that, hey, you have insufficient fund. And if you have that kind of balance, then you will then you will be deducting the amount from this balance, and that will be your new balance. Correct? So the amount that will be depositing, the amount that will be withdrawing is another amount that the consumer of this particular function some way need to provide it. And you will be also printing the current balance always. But while doing all these things, one fundamental thing is, you are not supposed to expose this variable to the consumer of create bank account function. If you have that use case, this is the perfect use case for Clojure. This is where you will be using Clojure. And with the definition of it again, now you have to close this particular variable into a function that you will be returning from this function, and inside that particular function everything else has to happen. Okay, but here we are talking about returning three functions. First let us do one. Let's start with deposit as a function. So you will do return deposit, and when you try to deposit something, what you do, you deposit an amount, right? So we will say depositing an amount, and what you do over here, whatever your existing balance, you do balance equals to balance plus amount. If you had 400 rupees balance in your account before, now you want to deposit another 100 rupees, your balance will be balance equals to previous balance, which was 400, plus the amount that you are depositing now, which is 100, so it will be total 500. Now after that, what I'm going to do, I'm just going to say console dot log, and we'll be saying deposited this amount, current balance is this amount. Okay, now this particular function create bank account having one functionality called deposit, but it doesn't expose this particular balance to the outside world. Now if you want to create an account, what you will do, you will do like const, say Tapascript is creating an account, Tapascript account equals to create bank account, and Tapascript is creating the bank account with say 100 USD. The moment I do this execution, this particular function execution is over. Once this function execution is over, it returns a new function called deposit to me. So that means if I have this Tapascript account, inside this Tapascript account, this deposit, this particular method is already assigned. This particular function is already assigned. So if I just do console dot log of Tapascript account. All right, look like here I have missed the function keyword. Yeah. Now at this point, if I go to my console, what I'm seeing over here is this deposit function. And inside this deposit function, you have balance equals to balance plus amount. At this stage, you really don't know what is the balance. That is the beauty of it. You have not really exposed the balance to the outside world. The moment you get an amount inside it, you are able to add it up, and then you are able to log it, like what is the amount that you have deposited and what is your current balance. But whatever was your balance, and somebody able to access this balance from outside directly or manipulate this balance from outside directly, those and all, there is no room of it. You have not left it because you are using Clojure. So now as Tapascript account is having this deposit as a function, so I can do one thing. I can call this function and deposit say 300 rupees. So it started with 100 rupees, and now I have deposited 300 rupees. So what will be the new balance? When this create bank account was initialized with 100 rupees, the balance was 100. When I'm calling this Tapascript account, which is nothing but this deposit function with another value 300, this 300 will go here, and it had already closed the balance 100 when I had executed the create bank account function. So now it will be a 300 plus 100 is 400 rupees balance. You want to see that console.log? Deposited 300, current balance is 400. You have that. Let's execute this one more time. Say I am earning too much. Now I want to deposit another 500 rupees. What do you think the output will be? Is the output will be 300 plus 100 400, and then 500 plus 100 600, or the output will be 300 plus 100 400 and 400 plus 500 900? What will be the output? Whether it is going to be 400 and 600 or 400 or 900? Let's see the out. It is 400 and 900. Why? The explanation comes with the same example that we have seen with count, because once this particular thing is closed inside this deposit, inside the closure will always remember the last value. It is never going to be reinitialized with the outer function, because outer function's lifespan is already over with this line. After this line, outer function's lifespan is no more, so it cannot really reinitialize this particular closed variable when you are calling a closure. When you are calling a closure is already memorizing your closed variable's value, and you will be using that memorized value every time you invoke it. So that's why first time when you initialize with 100, the balance was 100. When you invoke this deposit with 300, balance become 300 plus 100 is 400. Then again when you invoked with 500, it remembered the previous one because it closed the value balance with this 500, then did 500 plus 400 is, so remember the old value which was 400, so 400 plus 500 is now 900. So over here it is 400, over here it is 900. Excellent. This is how you should be using closure. Now let's make this particular bank account application little more realistic. We have added a deposit function. How about another function called withdraw? How about another function called check balance? Now I cannot return multiple functions from a single function, because from a function at one point of time you can return only one thing. Right now it is returning one function. I cannot really write this one over here, withdraw, and then I am passing an amount, and then I am doing a balance minus amount. I cannot do this because it is now look like returning two function. Now in this case you have to take an advantage of something called an object. We will be learning about object in details, but let's take an example of an object. Like in this kind of situation, how can you take advantage of an object to return multiple function definitions together so that you can use it along with closure in much flexible way? So instead of doing this return function, I'm just going to take out this guy. I'm just going to take out this guy. So I have a deposit function, I have a withdraw function. And what I'll be returning from here, see, stage by stage, I'll be returning an object. All right. The object will be always a key value pair. We know, right? The key can be any string. So that means I can take a key called deposit, and the value of this deposit can be any function. And this function can be an anonymous function, can be an arrow function, any function of your choice. So I can actually take up things from here to here. I'm just copying, put this guy over here. Either can give an anonymous function called function over here, or I can now write an arrow function like this, your choice. So that means I have a, instead of this one, a deposit as a key in my object, and the value itself is another function. Similarly, I can have one more key value pair, and then instead of deposit, I can now call it as withdraw, and I'm going to withdraw this much amount, and this amount will be deducted if I do withdraw, and I'll be saying here withdrawn this amount and current balance is this. Along with that, I can actually do a check over here saying that if, what if my amount that I'm going to withdraw is greater than the balance that I have in the bank, I am going to shout back saying that, hey boss, console.warn that insufficient fund. That's what I'm going to tell. Else, if that is not the case, I can always allow you to withdraw. So this is how I have my withdraw function defined. Similarly, I can do another key which say check balance, and the value of it can be another function, another arrow function, which can just have a console dot log of current balance comma the balance. It's just printing the balance. So now I don't need this as well. So this is my overall function. Create bank account starts with an initial balance, and then I am returning an object, and that object basically got three methods that I have defined. So if I now do this create bank account over here, create bank account, and I'm just going to get rid of all this thing and say that this is TapaScript account. Now if I do console.log of TapaScript account, previously it was returning me only the deposit function, but now I am returning an object itself. Object is nothing but a key value pair. Here my key is a string, is a deposit. You can do give it a double quote or omit the double quote, up to you. And the value of it is nothing but a function. Here also the value of it is a function. Here also the value of it is a function. So if I print TapaScript account as it is returning an object, it is going to print an object for me. So I'm seeing it has printed an object for me. The object has three key value pair. One is check balance, deposit, and withdraw. If I see any of them, the value is basically a function. That's what it is showing. It's a function. F means it's a function. Now, if I have to get back the deposit function, what will I do? Now this object has, of course, three key value pair, and when you want to access a value from an object, you have to always access the value using the key. Now if I want to access this deposit function, I have to access this using the key called deposit. So if this is the object dot deposit is going to return me this particular function. Object dot withdraw is going to return me this particular function. Object dot check balance going to return me this particular function. Okay, now I have TapaScript account, which is the object. So if I do TapaScript account dot deposit, what it is going to give me? It is going to give me, of course, this particular function. Now this function is again a closure, because it is accessing its outer functions balance variable and doing something with the balance variable, and of course not exposing the balance variable directly. So it has an access to its lexical scope, means its outer function, and after the execution of this function over here, it can still hold the value of the balance variable. It is closed on the balance variable. Excellent. So that means this one I can now very well call with, say, 300. That means I have initialized with the 100 rupees, and now I am depositing another 300. So now my deposit function will be called with this 300 as an amount, just like previously, and it will add it up to the balance, which was 100 initially. Now the balance will be 400. 100 plus 300. I'm expecting the balance should be 400. Let's go ahead and check this out. Yes, deposited 300, current balance is 400. Excellent. Now let me withdraw some amount. So for withdrawing, what I'm going to do, I'll be doing dot withdraw, and let me try to withdraw 700 rupees. In my account, I have now 400 rupees, but I'm trying to withdraw 700 rupees. Is it going to allow me? No, because this dot withdraw is going to go over here. 700 getting passed over here. Now it is checking whether 700 is greater than balance. What will be the balance over here at this line? At this line, either the balance is going to be 100, 300, or 400. Remember how closure works. Closure closed on this variable and remember its value. So it means that the comparison will be with 400, which is the latest value over here. So here it will be 700 greater than 400. Yes. So it will say insufficient fund. If I go over there, I see insufficient fund. You're seeing this particular warning. But what if I am trying to withdraw just 50 rupees? Now what will be the balance? The balance was 400 because it can memorize. Now 50 rupees I have withdrawn. So my balance will be 350. Is it working, your bank account? Now if you want to withdraw, say, 20 rupees here, 50 rupees again here, 150 rupees over here, what will be the balance? It was 350. Then it will be 350 minus 20, 330. Then 330 minus 50, 280. then 280 minus 150, it will be 130, isn't it? So if I go over there, I see that exactly like that. Now I want to check my current balance. What we'll be doing in that case, I'll be doing console.log of Tapascript account dot, I have something called check balance. I'll just call this. So moment I call check balance will call this one, which is printing a console.log of current balance, again accessing the balance variable. This balance variable value will be always remembered because this is also a closure, because it is accessing the variable from his lexical scope, his outer function, even after the outer function has been executed over here. So my current balance I should see as 130. Oops, here is a typo. It should be console.log. I have given 2n by mistake. So now let's see this. Yes, current balance is 130. Awesome. So if you spend another 5 minutes yourself going through this create bank account function, and how I have explained it, broken it, built it using object, again showed it to you while taking the value of it, which itself is a closure, how it is remembering the value. You have actually built a banking application, an ATM application in front of you using closure. This is the real life example of a closure where the balance you are not exposing through this create bank account at all, because your balance don't have to be exposed to deposit an account and withdraw an account. This is what ATM has to know. If you want to know as a user the balance, you just call this check balance. But for withdrawing, you don't have to really know what is the current balance. Deposit, you really don't have to know what is the current balance. ATM machine has to know. You have programmed an ATM machine using closure. Isn't it fun? So as we have learned that a closure can hold the reference of a variable that is declared in the outer function, means its lexical scope. As it is holding a reference, this balance, so every time you were invoking it, it had always the latest value. That's the biggest advantage of closure. But the same advantage can go as a disadvantage for you if you are not bit careful. And closure can cause you memory leak, a problem with your memory misutilization as well. So while learning why closure is useful, you also need to learn like where exactly you should not be using closure, or you need to be careful around it. For example, if you're dealing with some big data, let's say I have a function and say function name is dealing with big data. Now, what this function does, let's say I am creating a big data. For this kind of situation, no, you can always use an array just for demonstration. We have not learned array, but let's understand that there is an array using which you can create and a pool of elements. So let's create this big array and then fill this array with a character, let's say star character. So what is big data going to be? If I just do console.log of big data, and then I'll invoke this function dealing with big data, and then let's see the output for a moment. You see that it's an array of this many element, and every element is a star. It's so big that it is not able to even show it over here. It's a big one, big array. Now let's bring closure to this. Instead of doing console.log big data here, let me return a function from it, which is a closure only if it access the variable from its lexical scope, means the outer function, after the execution of the outer function. Correct, na? So returning a function, and here I am doing a console.log of say big data, and I am accessing the fourth variable of the big data. Number 3 means array always starts with the 0th index. So 0, 1, 2, 3, fourth element I am accessing. Now this dealing with big data, when I execute, it is returning this function. So let's take this function inside a variable. Okay, I've given some variable name. Now this variable 1, 2 is having this particular function. Now if I do console.log of variable 1, 2, which is a function to execute one parenthesis, what it is going to return? It is going to return me the fourth element from this big data array. In the big data array, every element is a asterisk sign. So fourth element also will be an asterisk sign. Great. So if I go over here in my console, I'm seeing one asterisk element. I'm not seeing that big asterisk list anymore because I'm not printing the entire big data. I am just interested in the fourth element of that big data. This is great. Everything is working fine. But slowly, one problem we have introduced. This closure variable 1, 2 is having a reference of this particular big data array. That means every time I am invoking variable 1, 2, this big data is always in the memory, always will be kept in the memory, always will be referenced from variable 1, 2. Do you remember the execution context session where I have showed it very specifically that if somebody is pointing to a memory location or there is a reference to a memory location, garbage collector is not going to come and clean it up. Garbage collector is going to come and clean it up only when there is no reference available to that memory location from anywhere. But in this case, variable 1, 2 is having a reference to this big data, and that's why it is able to bring out the fourth element from this big data array. So it means this big data is never ever going to get cleaned up. You think about the situation, the bigger the array is, the more the memory location and more thing you are dealing with memory without it being getting garbage collected. So when you are using closure, please remember in what situation you are using closure. In this situation, if you're using closure, you might end up having a memory leak, and this is where you have to avoid using unnecessary closure when you are dealing with memory heavy application or the big data application. But for the previous example like this is the perfect place where you will be using closure. So now as we understand what is closure and where you should be using, where you should not be using, let us just list down the type of advantages that we get with closure overall. And the reason that I want to list down, because when I'll be writing these advantages over here, you should be relating with each of the examples that we have taken over here. We have taken some examples like that count example, this bank account example, the first example where the outer inner was there. And then I'm also going to show you one more example right after writing it, where I'll be using the timer function to show you something about the closure. All right. So let's do this. So the first advantage that we get is like you can keep the variables private without exposing them. First advantage. As you are able to do it, you can stop variable pollution. What does it mean? You can stop from polluting a variable. That means if it is not exposed outside, nobody can access the variable directly, nobody can change that variable directly. It has to be changed always using the closure, always using the function. What is the third advantage? You can create a function factory. What is function factory? What is factory? Factory is a place where you make several things and then ship it. If you take a look into this particular example of creating a bank account, it is like a factory because it has bunch of methods that are related to a bank account creation. For example, depositing, withdrawing, checking the balance, etc. So it's a factory of method, and it is possible to create this factory of method and keeping this balance in sync only using the closure. So that's why the another advantage that you can write is like you can create a function factory. Fourth, the great usefulness that we have seen is like you can keep a variable alive between multiple calls. Don't you think so? Whenever I'm calling deposit, multiple time withdraw, check balance, etc., I was able to keep this balance variable alive across multiple closure, across multiple functions, because all the closure had the access to the same outer variable. So that means that of that outer variable's lifetime, you can manage across all the functions and keep it alive between the multiple calls of those functions. Isn't that awesome? So let's quickly take one more example so that all this thing get printed in your mind. So let's do a function called timer. And in this timer function, let us take seconds as my variable. And then I'm going to return another function from here, which will be my closure, because it is going to access what? The variable from the lexical scope. And what it is going to do, it is going to increase this seconds by 1. Every time we call it, it is going to increase the seconds by 1. And then I am doing console dot log of elapsed seconds comma this particular variable. Now if I call timer is going to return me this particular function, and timer's execution is done over here. Let me take it in a variable called timer instance, and this timer instance is now a function because timer returned this function. So if I call timer instance once, it will increase, twice it will increase, third time it will increase. So first time timer instance will be elapsed seconds is seconds means increased by 1, so it will be 1. Here it will be increased by another one, so it will be 2 because it can memorize, it have the reference to that variable, and it will be 3. So it will be elapsed seconds 1, elapsed seconds 2, elapsed seconds 3. Okay, so here is a typo. I'll call it function. Now let's go back and see the thing. Here elapsed seconds 1, elapsed seconds 2, elapsed seconds 3. Many of you who are already working on JavaScript or even with libraries like React or framework like Next.js, you must be dealing with something called event handler. In fact, our next module is all about DOM. That is where we'll be seeing a lot of event handlers. But if you even don't know about event handler, DOM and anything, just forget about it and focus on the code snippet that I'm showing you on the screen. What is happening over here? Assume I have a button called my button on my HTML. Now the button got an ID called my button, and I'm able to access that particular button using its ID. Document.getElement by ID. Once I pass the ID, I will get that particular button instance. And on that button, now I am adding a click handler. What is click handler? It means that whenever someone click on that button, something has to happen, right? When you click on a button, you will be sending a message, show something, hide something, send a network call, something you will do. What you will do to define that, you need a click handler. That click handler defining what it has to be done using this function. So anything and everything that you write inside this function is going to get executed when someone click on this particular button. Now here there is a beautiful usage of closure. You might be already doing, maybe without knowing that you are using a closure. Let me explain that. So here if you see, I have a variable called click count and initialized with 0. Now there is a button. When a click event happen, when a click action happen, I increase the value of it by 1 and I print it over here. Now on the first click, the count value will be 1. Now on the second click, is the count value will be again 1 or 2? This is the question that I have. Now if you know about closure, you can give the answer from the closure itself. How? What is the closure's funda? Closure's definition, as I told, closure is a function that can access the variable from its outer function or from lexical scope even after the outer function's execution is done. Outer function is setup button whose execution is done here already. Outer function having a inner function. This is the inner function over here, and this inner function is closing on this variable called click count. So that means setup button has already assigned this particular function execution through the event handler to this button. You click on the button first time, this function will be called. You click on the button second time, this function will be called. Third time, this function will be called. Now every time this function will be called, the function will have a reference to this click count variable because it is closing on it. So first time the value was 0, it will increment it to 1. Second time when somebody will click, it will always have the updated value because it will memorize that value through the references. We have seen with closure examples, so many examples so far. So second time the value will be 2. Again you will click, value will be 3, value will be 4. So this is the reason, because it is a closure, it can have a reference to the value, it can memorize the value. And why it is closure, we know it by its definition. That is why it will behave in this way. Every time you click, it will show you the incremented number, not that it will only show 0 to 1, 0 to 0 to 1, 0 to 1. It is going to show 1, 2, 3, 4, 5 every time you click. So this is another example, another usage of closure in your programming. I hope you remember that. So if you have come this far, congratulations to you and me both. To you because you have completed closure, you understand what closure is. To me because I was able to articulate what closure is, and I hope it was better, it was good, and you understood it completely. If so, please let me know with a comment that you have a better grip on closure now. Now to make the grip even better, I would say please complete the task. Where can you find the task? Please go to github.com/tapascript, go to repositories. You will find 40 days of JavaScript, and here you will have everyday sessions. Like today's day 11, you will find day 11. Inside day 11, you will find task.md, and you will have all the tasks listed for you to try out. If you stuck, please come to our Discord, start discussing about why you stuck, what problem you're facing. We'll get back to you, either me or anyone from the community. If you complete your task, make sure you come to 40 days of JavaScript. In the task assignment channel, you post your task. Let's be active, let's learn. And I'm very proud of each of you who are putting your complete effort in learning JavaScript, doing the task, completing them, and waiting for the next session. Thank you very much, guys. Please post a like to this video. Please share about 40 days of JavaScript among your coding buddies. I'll be coming back again with the day 12 with another fantastic session.